All right, hi, this is question 24 from the January 2023 statewide test, and it says, evaluate the limit of cosine squared x minus sine squared x, all raised to the power of 1 over x as x approaches 0. So usually the first thing you would do when you're evaluating a limit is plug in whatever x is approaching. But if we did that here, we would get that the function was raised to the power of 1 over 0, which I don't know about you, but I don't think we can have a limit of something raised to an undefined form. So let's not do that, and instead, we should notice that the limit has an exponent in it. The exponent is the problem here, right? And so what that usually means is we should think about taking the natural log of that limit, because natural logs, or just logarithms in general, do have that pretty neat property where the log of a raised to the power of b is equal to b log a. Right, so we're going to take advantage of that and take the natural log of this limit. So we have that L, our limit, that's equal to, the limit as x approaches 0 of cosine squared x minus sine squared x, which hopefully you recognize is the trig identity for the cosine of 2x all raised to 1 over x. Now, if we were to take the natural log of that limit L, we would get the natural log of our aforementioned limit. And so what we can actually do with this sort of thing is we can, instead of taking the natural log of the limit, is we can flip it and take the limit of the natural log. So that's what I'm going to do right here. Now what? Well, remember, the exponent is the problem, so we're going to use this rule and change this to the limit as x approaches 0 of 1 over x times the natural log of cosine of 2x. But I'm going to write that a little differently. I'm going to write it as the natural log of cosine of 2x over x. It's the same thing though. So now what? Hopefully it works, right? Well, we plug in x, we get the natural log, on the numerator we get the natural log of cosine of 0, which is the natural log of 1, which is 0. On the bottom, we also get 0. Crap. This evaluates to 0 over 0, which is indeterminate, which sucks, but actually not really, because the nice thing about this is when we get a limit with a result of 0 over 0, we can use L'Hopital's or however you say its name. We can use that rule, and we know that the limit is equal to the limit of the derivative of the numerator divided by the limit of the derivative of the denominator. So that's what we're going to do, and let's see what happens. So I'm going to say the derivative of the natural log of our limit is equal to the limit as x approaches 0 of the derivative of the numerator, which is 1 over cosine of 2x, but we can't forget to multiply this by negative sine 2x times 2 by chain rule. And then we also have to divide this by the derivative of x, which is the denominator. But that's just 1, so it doesn't really do much. I mean, there's a 1 there, but it doesn't do much. So I'm just going to leave it there. And so now we're going to evaluate this. And what do we get? Well, on the top, we get the sine of 0 times 2, which is just 0. And then on the bottom, we get cosine of 0, which is 1. So now this actually evaluates to something real. So this evaluates to 0, right? So just be careful that you don't get too excited and click 0 as your answer, because remember, this is the natural log of the limit that evaluates to 0. We want to take the anti-log of that, get rid of this, and so our answer is e to the 0th power, which is equal to 1.